So, I'm Ben Striegel. I have been working on Rust for almost 3 years now, kind of just in a volunteer capacity. Unlike Alex, who is an actual Rust developer, gets paid more envious. So Justin kind of asked me to give an introduction to Rust, and this was last month when I didn't realize that I wouldn't be the most experienced developer in Pittsburgh. So I would have made Alex do it if I had known. It's pretty sly. Anyway, also I want to say real quick, Carol knows this, I've seen the sign. I tend to talk really fast when I get excited and slur my speech and mumble. Just like throw things at me if I do that. So I'm sure about like a Nerf gun you shoot at me or something, I don't know. But yeah, so generally when I've been to kind of like introductions or like watch them online, very often they're kind of like really code heavy and kind of like, well, this is how we make a string in our language. And I don't think it's really interesting because you put that online somewhere. I really want to talk more about kind of the impetus for Rust and the philosophy behind Rust and the community around Rust. And like, you know, introduction to Rust as a project, as a whole, instead of just kind of like the language itself, how it looks today. Especially because Rust changes so fast that how it looks today might change tomorrow. Not really, but that's how it feels sometimes. In any case, so I think the first real thing to go over here is kind of, we made a language, programming language. Why do we need more of these? Not just a language, we made a systems programming language. And do we really need more of those in the first place? So I think we have to first answer that question. I mean, so like kind of like litmus test for like knowing how to set up this talk is I want to ask, how many people in here could like write hello world in C++ top of their head? Like, yeah, I don't remember the includes either. So kind of like half. So really, I think a lot of the time, like nowadays, we feel like, thankfully, we don't need a language like C very often anymore. We have our Perls and Pythons and Rubies, especially Ruby. Is anyone here Ruby essentially? I know we're in yes, so pretty much yes. Okay. So especially these kind of things where, you know, they're definitely optimized for programmer happiness, as Carol wants to remind me. I tell her that's irrelevant. Just kidding.
So that was crap.
Crap. That was the word. Anyway. And so, first thing we need is definitely a hard sell. Because I mean, people, they want to say, 2014, why do we care about memory layout or allocation or any kind of like these low-level concepts? Should we have like compilers care about that? And the answer is yes, you should. If you have garbage collection and you can get away with it, I think you should use it. Because it is like a huge, big deal. It was like, so they say there's no silver bullet, but GC was probably as close as we ever got to a silver bullet in terms of like freeing us from like memory errors. But it doesn't like fix every problem. I say that a lot too. I apologize for that in advance. I apologize a lot too. I apologize for that in advance. And so we spent like in the past 20 years or so, you know, first with Java and everyone else kind of like working really hard in garbage collection and in JavaScript. Past decade or so, like really working hard to make this convenient and fast as we can. So questions are, why do we still need any kind of languages in this vein? And if we do, then why Rust? What does Rust actually address? Because we need to have a purpose. I mean, looking at all those languages, when they get made, kind of get made for the reason that Ruby was made, where a programmer sitting there thinking, I hate this language that I'm using. I'm smart. I'll make my own language. So Rust kind of started like that, but for different reasons. It wasn't made for programmer happiness, it was made for user happiness. Because we want to stop crashes, we want to stop memory-based stuff lead to exploits, memory unsafety, lead to exploits in code. So, I mean, all the time, I feel like the purpose of Rust is to make the world a better place in a very naive way, sometimes. But if we can dissuade people from using an unsafe language where necessary, I think it's a big win for us. A big win for all of us in terms of like, I use software on my computer that's written in C++. It's hugely unsafe all the time. And so I don't know if there aren't any exploits. I don't know if I'm being targeted at all. So you don't need to be paranoid to benefit from these things. Anyway, so the first kind of thing I want to address here is that, you know, people write, like the big deal nowadays is that, like, first of all, do you even have a target for this, like a target demo for this? Because nowadays it seems like pretty much everyone's either writing for Android with Java or compiled to Java language, or iOS with Swift, Gypsy, and web apps, obviously. So I mean, like, what platforms do you want to write this language for? I mean, do we really need more apps written in languages like C++? I mean, who like, you know, does anything except for maybe Photoshop or audio manipulation, video manipulation on the server, so on the desktop. And the reason for that is that maybe, okay, so say you have like your web app written in Python, but you have your implementation written in C, and that, is behind a web server written in C. And that's behind, say, a cache written in C. And that sits on an operating system written in C, which is all on a hypervisor written in C. Calling out to libraries like gzip and regex and the libraries all written in C. Calling to the network to your clients who are running browsers written in C. Using hardware on the network, which is all the IP stuff written in C. So I mean, we have a giant mountain of system software, and on top here, the cap of the pyramid is the web app, the Ruby, the Python, and everything else. And kind of if you have any slowness in this lower stack, then you definitely that impacts here. So it all trickles down. So you want to definitely emphasize speed above all. And the next kind of argument here is, well, we have our web servers and our caching servers, and we have our OSs. We're not going to rewrite these. We just have these and they work. So why do we need new language if we don't need to write new things? And the reason is, I think it's kind of a short of the when you think, because we didn't need to rewrite Apache. It worked, but then someone did. Some guy in Russia. It's made in Unix, and now Unix is I think it's the most popular. It took Apache actually recently in the top 1,000 sites. So and then think of Ruby implementations. So how many are there? There's MRI, there's Rubinius, there's JRuby, there's RubyMotion, Topaz. These are all, I think, written for the impetus of we want a faster implementation. Speed is the reason, and efficiency is the reason. And also, sometimes there are really old, really crusty software that we have, like web browsers, hint, foreshadowing, that we want to apply new techniques to and research techniques to, but we can't really do that within the constraints of a giant multi-million line code base written in C++. And the next kind of point is, so say we have established that we need a language that's really, really fast. And so why can't current languages like Java do this? Because we've shown that Java can be as fast as C in certain circumstances. It's getting faster all the time. And actually people haven't really, as far as I've seen, kind of to quantify the difference between Java and C++ and the performance capacity very often. The most recent paper that I saw was from 2005, and it's called Quantifying the Performance of Garbage Collection versus Explicit Memory Management. And in that paper, they did show that when you have 5 times enough memory as a C program, or a manually managed memory program, you can get as fast. But if you only have 3 times, then you are about 3/4 as fast. And if you have only 2 times, you're about 1/3 as fast. And so, given these effects, these kind of exponential fall off as you reduce memory, it's a big deal. So even though Java, which is a great implementation, again, definitely a big deal that we have garbage collection systems really this well honed for millions of man hours, but it's not always appropriate. And the next kind of argument is, well, does it matter we need more memory to do these? Because we have memory is free nowadays, basically, right? So we have phones with how many gigs nowadays does the iPhone have? Of RAM? It's 2? Is it 4 yet? I don't know. I don't have an iPhone, but Troy. Anyway, so, but I think it's kind of also a short-sighted argument because, people are saying, well, the phone's getting faster and faster, but we didn't have smartphones until the hardware was fast enough. And then they took a performance hit to put a new form factor, a new computing form factor. And I think that as things get faster and memory gets cheaper and, physical smaller spaces, we'll find even smaller form factors that, again, take a performance hit like we saw going from laptops to phones. So I think definitely there's room for more languages at this level. And think even beyond new platforms. So you say there's people remembering about the Internet of Things or wearable hardware where your shirt has a chip and shoes have chips and your Cheetos have chips in them. I don't know. Not sure why, but why not? We can do this nowadays. It's magic. It's the future. So I think really we do need new languages like this. Or at least these languages are important. I haven't established we need new ones yet. But so if we need languages like C and C++, what are the deficiencies of these languages? Because they're well established, they're very mature, They have huge tooling. Everyone knows them, basically, or at least heard of them. They're wildly popular. So why don't we try to make a new one? How can we even try to compete with these? And it's a good question. So I don't think I need to explain how C++ and C are kind of a bit unsafe. I remember, actually, I was sitting in computer science class at Allegheny College. And it was our first C programming class. It was like second year or something. And previously, we'd only used Java. I used Java in high school, too. And I found that program, and I ran it, and just said segmentation fault. And I called the TA over. I'm like, what's this? He's just like, and like walks away. He wasn't a very good TA. So, but yeah, so C and C++ are kind of designed for an age where nobody really had solved the problem of how do you avoid seg faults while still allowing these kind of unhindered access to the hardware. And a lot of people don't realize that it's not a solved problem, but there are solutions available for us. And Rust had one of those solutions. And the solution is kind of sometimes called linear types, but really gives it more as kind of like ownership in a type system, which also isn't really correct, but we have bad marketing, whatever. And at this point, I think an unusual presentation. I would drop into code and show you, exactly how linear types interact and how they do things. But I kind of want to keep it high level here and just say that usually what happens is we have C and C++ for this AppleJuice, and they're way over here. They say we are close to the hardware. We are AppleJuice. And over here we have Ruby. It is high level. Or say it is Pascal or Prolog. It's way up here. It's in your brain. It's mango juice. And there's really a dichotomy there. And I think that people don't realize that there is a solution to that, which is what Rust has here, and it's kind of only vaguely explored in the space of languages in the past few years. Rust is really the first language to really dig out deep and say, hey, what if we design an entire language around this? And I think it really started, when did unique pointer show up in Boost? Was it like 2006 or so? Yeah, so Boost is a C++ library, and where it kind of like began the idea of having a single pointer, or a single owner for any given piece of data. And what's cool about this is when you know who owns data, you know whose responsibility it is to free the data. And really, the hard part for managing memory manually isn't allocating, it's the freeing part, right? So when you free, you have to make sure that no one else frees it. You have to make sure that somebody frees it, must be memory leaks. You have to make sure that after you free it, no one else tries to read it. So all these kind of issues. And what Rust does is, Rust says, hey, whereas C++ and C let you kind of just hand out pointers willy-nilly to anyone who wants one. Instead, what we'll do is, we have a single owner. And this person, this pointer, is the one that will allocate the pointer, allocate the data, track it, hand it off if it needs to, and then free it when no one else wants it. Think of it kind of like, it's hard to describe with our current term. Think of it as like automatic manual memory management. The problem in the past with this, people who have tried implementing this kind of concept, is that it's a very actually onerous restricted practice to only have a single owner. So say you want to like have a piece of data, call it A. You want to do A plus A. Well, how would you do that? You can't move a thing into a function twice under the same owner. You have to like do a manual copy or something like that. And that can get really onerous for lots of data. And so what Rust did was Rust took a separate concept, which is called regions in academic literature. We call them lifetimes. And we simplified them a great deal. And the idea of this is we use lifetimes to track references to pointers. And if you're familiar with like references in a C++ sense, really a reference is kind of like in C++. In Rust, a reference is just a pointer at runtime. There's no overhead. It's entirely free, but it is a pointer that doesn't own. And the Rust compiler, because it knows who owns it, it knows how long that owner lives, it knows how long the reference lives. And with this reference thing, we can do like crazy things. So we can do things like, normally in C++, it's very dangerous to store a reference somewhere, like just into random memory, because you never really know who owns that memory, what's going to be freed. In Rust, it's totally safe. It's a really big feature of Rust, in fact, with some downsides as well. But it's totally safe because we have the system. In fact, the idea of Rust is that for almost all code you write, it is all safe. Like, as long as you trust the compiler to not screw up, which it might, we can't prove it won't, but we're reasonably sure it won't at this point. Your code will not segfault, it will not double free, it will not blow the stack, won't do any of this stuff. Or won't. I'm sorry with terminology. And you should ask Alex, because he knows all about this stuff. He's very smart. Also, again, I'm not really a genius, so if I say something wrong, I apologize. Feel free to shout out and correct me if I do. So, I'm also not a very good public speaker. As you may have seen, I have no slides, but I don't believe in slides. And again, in this right middle, it's very colorful. And so, as I just mentioned, I'm not really a systems programmer. I think that when we say stuff like we have ownership in the type system or these kind of concepts, people kind of like, they've been conditioned with type systems to think in their head, well, type system is some kind of like what Scala has or what Haskell has. Scala has, I'm sorry. Or is Haskell, I can't pronounce either of these languages' names, I'm sorry. Rust is pronounced Rust, by the way. No big deal. I get sidetracked. I recall thinking in straight lines. Type systems, thank you. Thing is, though, I mean, so these languages kind of get an unfair rap. It's kind of like, well, you need a degree in like a PhD in category theory to understand what's actually going on with these systems. I think Rust, I don't think it's true at all. Like, so, for example, I am not a genius. I'm a not genius, and I can understand Rust. I read tutorial literature too, but it didn't take me 3 years to learn. It took me like 3 months to kind of figure it out. And I basically, for a day job, write really bad JavaScript and PHP. And I can figure it out. So I'm not going to say Rust is a language for idiots, because there's some people who write Rust. But I might be an idiot in some context, and I can write Rust, so it's not really a big deal. I don't want people to think that Rust is some like high-level gobbledygook you can't really understand, because this concept of lifetimes that we've named, it already exists. It's not a new concept. It exists in C++. Thank you. It exists in C and C++. If you want, as I said before, to keep your code from double freeing or not freeing at all, you have to know in your head the lifetimes. You have to track them manually. For example, so it's kind of like where I work, we have a language called RPGLE. RPGLE is a column-based programming languages. So you have an if statement, below it, another if statement. Indentation is not allowed. So what my people at my work do is they print out the paper and they get highlighters and they highlight the blocks. It's true. Alex is writhing and laughing at the same time right now. But it's true, and it's kind of like, this is kind of what people who write C++ do in their head. They have to know the lifetimes of code, and they have to keep track of it manually, and there's no really check on that. So what Rust does is kind of like reifies this notion. It brings it into the language itself, and it really frees you. It's liberating. I've kind of noticed 2 big audiences for people coming to Rust, and one is C++ developers who want the speed of C++, but really desire the safety. And again, the people are the kind of like Rubyists and the Python programmers, they're like me, JavaScript programmer, who wants the speed of C++, but also wants the safety that I'm used to of languages. And again, the whole like the mind-blowing idea of Rust is that this is possible. Is that it's absolutely possible. The trade-off is it's a bit more difficult to do certain things you're accustomed to. So these lifetime pointers, these borrowed references, again, so even though they're kind of like, they make our system of linear types or ownership so much more usable, it's still some things you can't do just with those. And again, we are a systems programming language. We have to give you a recourse for this. So there are certain like dirty tricks that you can do in C or C++ that let you do all kinds of stuff, and some of it is totally legit. And we need to be able to compete at this level. And so the reason, for example, I mean, we all know C++. It's kind of a widely unloved language. So there are all kinds of like complaints against it, like it's huge, it's hard to parse, it's very slow to compile. Even Jan Striegel, who is on the committee for C++, thinks it's a joke, the committee itself. And it's kind of like, but it's hugely successful. And the reason for that is that it has kind of like fanatical focus on keeping things zero cost, of being able to say, hey, no matter what we implement here, there's abstractions that they won't penalize you. If you're not using them, if you are using them, they still will be very low overhead. And so Rust has the same approach. The only only have one exception to this rule, which is we bounds check arrays on access. Because there's not many ways of removing that check safely. In like 10 years there will be, but not today. Rust isn't the language for 10 years from now. It's a language for this year, 2014, and I think it's really cool. So, where was I? Oh, awesome. So, the history of Rust is kind of like, there's a man named Graydon Hoare who worked in Mozilla for a long time, kind of worked on the Trace Monkey engine for Mozilla, all kinds of stuff, kind of fiddling around in Mozilla research. He kind of like was using C++, and he kind of thought to himself, man, I kind of don't like this language. For all the mentioned years mentioned previously, and he wanted to make a better one. Like every programmer does, except for. It's kind of like, well, I just want a language that isn't C++ that I can write for my day job, which is the dream, right? So Mozilla go into this with his employer, and so the question you'd be asking yourself is, why does Mozilla write a new language? Like, what's the point of this? I mean, like, maybe you have associations of Mozilla with JavaScript, for example, or which is, isn't the most flattering parallel. But the reason for this is that Mozilla maintains Gecko, which is a slave engine written in C++, with roots dating back to 1998, I believe. And it's very old, it's very well optimized, it contains a lot of kind of dirty hacks to get the speed that it does. And in the meantime, since 1998, things have changed a little bit. So nowadays, computers are faster, but they've kind of hit a wall a while ago, and now they're all about more cores. But tacking on concurrency to a multi-million line code base like Gecko is a very harrowing prospect. And even like the Chrome team, which started, so web kind of like has its own roots back to 1998 or so. When did WebKit start? HTML, a long time ago. Kind of like they're still working really hard to kind of like figure out where it is safe concurrency in, and then like doing it when they can and measuring it. But Mozilla said, well, it'd be really tough to do this while maintaining a really like brisk development process. So they decided that instead of trying to tack C++ on their current engine, they wanted to make a new engine just for experimentation with concurrency, and then say, hey, if it's a win in this new engine, then we can try it in Gecko. And they realized too that it would be a huge pain in the butt to try and do this in C++, given the poor support for concurrency that it already has, and unsafety too, which is kind of just like, if you do it in C++, you're kind of in the same boat 10 years later. So they someone got wind of, I'm not sure who in the first place, heard about Rust and Graydon. Maybe it was D. Herman, I don't know. But they got wind of it and they started sponsoring it. And so at this point, Servo has been under development for about 2 years now, probably, kind of very painfully, while Rust has been breaking everything every month or so. But so far, in Servo, I think HTML parsing is parallel, CSS parsing is parallel, layout's parallel, pages are rendered in parallel, tabs, like iframes are written in parallel, everything's parallel. I think it's a huge triumph of concurrency and like leveraging these cores. And it's really proven itself to be a real kind of like point of pride for Mozilla research to have this kind of engine really pushing down the envelope here. In ways that other engines just can't match because of all the legacy we have. So it's a very neat thing that we have here. And so again, like Rust emphasis isn't just low-level code and safety, it's also concurrency. Because thread safety and concurrency bugs are a huge vein. It's like, I think people were kind of like 10 years ago predicting that we'd never be able to actually make use of all these cores that we're having because who can write effective and parallel code? And Rust, because again, of our type system, which there's something different about it. It's again just linear types and bar pointers. It's impossible to get data races. And we know this at compile time. If you would race on data, we would throw an error when you try to compile the program. So it's a really cool thing. It just falls out of our usual rules. Because we've just actually established a thing by accident entirely, which I'm sure Alex has heard many times, is that the problem with concurrent programming is shared mutable state, which is kind of like how you share things in the typical kind of thread model of C++. And with functional programming, you hear that it's triply parallelizable because they get rid of the mutable part. So functional data structures, they're all entirely immutable. So you make a copy if you want a new one, and you can't race on those because they're entirely new structures. Rust takes the other approach. Instead of saying, well, taking the mutable out of shared mutable, take the shared out. So we have Alias Ability, Essentially, when you know ownership, you know who aliases your pointers, and you know who can access those pointers. And so you can mutate data across several threads safely. And it's a very cool thing. So, and at the same time, Mozilla, they've been targeting the typical platforms for Firefox. There's Linux, Mac OS 10, and Windows are all first class, but the community has contributed lots of fixes also for patches for iOS support just landed. We've had Android support for a while. I think Samsung gave us that. People are doing all kinds of things with ARM, too. So ARM board, Raspberry Pi. So I know a person who isn't paying attention mentioned that robots is a big thing. Mentioned robots, and I think that's really cool. I'll talk more on that, because I think it's really cool seeing all these low-level applications where previously only C would be feasible. And Rust, because it has no garbage collection, it's still memory safe, doesn't need any kind of runtime. And a runtime is kind of like you run Ruby or Python. Runtime is the program below it, making sure, imagine a runtime as a nanny, where nanny cleans up your trash after you're done and kind of puts it away in her box for you. So Rust code doesn't need this. It can run entirely headless. And if you run without a runtime, you don't get any of the kind of, do we offer native threads in runtimes? So we don't have kind of multiplexed green threads, but we have native threads still available and still safe. What's that? We have with green in runtimes? Really? I don't think we do that. It's amazing. Okay, anyway, I have some more than I do. What don't we do then? What does runtime mode actually do anymore? No allocation. No allocation, so that's it, I guess. Which is pretty cool. So we're entirely suitable for writing, say, if you wanted to mention before in the list of applications where C is used still, where you have write your library in regex. Someone wrote libpcre a million years ago, still using it. But if you wanted to, someone wrote libre2 a while ago, eventually ensure maybe you'll learn a new process for regular expressions. Someone can do that in Rust. You can write a library in Rust you can call from Python and Ruby and everything else, because Rust can expose the C interface and run without a runtime. So that's kind of the coolest thing. People have written OS kernels in Rust. Those are pretty painful because you need a lot of unsafe code and assembly code. But still, their tagline is that even unsafe Rust is safer than C, because we still have checks in place in a lot of cases that you have to turn off manually. So you have to disable balance checking. You have to manually opt in to places in code where you want to do raw pointer access and assembly code, and everywhere else, it's still entirely safe. So, yeah, that's pretty cool. And so, in the end, this is long. In the end, Rust is kind of it's a strange saddle between, or saddles the line between a research language and a production language, because we have both kind of people with legitimate honest to God degrees in language theory that work on it, but also really practical, pragmatic C++ programmers working on it, and they're both kind of refining it from different ends to make a really cohesive product in the end. I think it's going to be really, really cool. So I like to call Rust kind of a language researching practicality and pragmatism, because we really want to make this usable. So we really focus a lot about reducing pain points and stress while still retaining safety and furious performance, uncompromising performance. And we have a really big community around it. So, Rust, like I said, we have all these backends contributed by people in the community. We have, huge libraries. Someone just wrote us a compile-time regex library. His name is Burnt Sushi. I'm not sure what his real name is.
Andrew Gallant.
Andrew Gallant? Okay, that's cool. Yeah, it's just, there's that, what this compile-time regex library does, it uses our macro system, and it compiles your regex to a state machine at compile time, and then runs state machine at runtime. And it's really cool. It's amazing, actually. So we have a huge community around it, I think. So I wanted to just kind of. So again, this is really an introduction to using Rust itself. You can find these online. We have some resources here. And I apologize. If you give me your email address later, I can send you some of the resources too. But this is kind of basically called Rust by Example, which is a website. So on the side here is kind of a gentle introduction to Rust. Community never made this, of one concept at a time. And these are all entirely runnable code examples. You can edit if you want. So that's really cool. So this is called Rust by Example. That's super neat. If you want help, we have a Stack Overflow tag. It's kind of sparse at the moment, only about 400 questions, but there are many people on there I've never even heard of before answering Rust questions. I'm like, it's really cool how like eventually the community is getting so big that I don't even know anyone anymore. Like, I've never heard this person before in my life. We have documentation ourselves, so if you go to ruston.org and then up here in documentation, usually about the version of 0.10, it's garbage. API docs, and I'm like, well, how do I read Rust? And read all kinds of crap in there. We're working on libraries to kind of up here right now. Again, so, and then I should mention though too, is that I keep joking that Rust is breaking things all the time. The language itself is relatively stable right now, but the library is kind of in a flux. We're trying to get out a 1.0 release to something 1.0. You over there? So we're working on that. Sometime this year, we think we'll have something that's really stable that you can just use without breaking anymore. Until that point though, we will be breaking things, especially in the libraries, even at 1.0. Not all libraries will be stable, but if you start using unstable ones, you have to like manually opt into it. It'll kind of warn you and be like, hey, this library is kind of experimental, just so you know, and things might break. So, yeah, it's kind of, I really do want to warn you, 1.0 doesn't mean the libraries will all be usable at that point. They will warn you if they're not usable, if they're not guaranteed backward compatibility, but many of them will be compatible at that point. If you have problems, we have a GitHub repository. So we have just rustlang/rust, lots of contributors, lots of commits. Actually, it was amusing to see GitHub did a summary last year of all kinds of stats on like a year in GitHub, and we were the repository with the 5th highest rate of closed issues. So we've almost overtaken Rails for total number of issues. Like we're like 800 away. I'm really excited to take this next time. Now we have an IRC channel on irc.mozilla.org, and right now it has about like I think a little under 600 people in it. So let's hope they're not talking to Mr. Whipple. And you can obviously use IRC by this web client or your own personal client. So I'm just going to say. It says hi. Mr. Whipple, no one will know who that was. Anyway, we have a Reddit, which is has about like subscribe to it. It's kind of like mostly it's a news aggregator where you kind of keep up on progress in language. There are people who kind of so every week a community member puts out this thing called This Week in Rust, which is just a summary of the changes that have happened in the past week. That's Corey. He's super cool. We have people just kind of like posting about personal projects or asking for code reviews, kind of learning the language. So you're welcome to come here, use this as a resource. We have, this is the engine that powers the code examples on the Rustbyte example. And you can just come here and you can just play around, and if you want, you can link to any code example and then show them around. If you want to like say, hey, how do I do this in IRC? Just link to it. And then, so, I mean, it's kind of one more to the community here is I made a little map here of, this is a list of GitHub contributors gotten from scraping GitHub in terms of location that they identify with on GitHub. And for the top 100 contributors, we have these magnitude circles. GitHub doesn't give me magnitude, or kind of terms of like lines of code committed per person. But everyone doesn't give any kind of information. It's down here floating in the RPC. But everyone else is around. I'm really encouraged to see people from India, Australia, Brazil, Russia, lots of South Korea, Japan, and China, all that, all throughout Europe, lots of stuff. So it's very cool. So yeah, hope that suffices as introduction to Rust. If you have any examples, you can ask me or Alex afterwards. And I have stickers in 2 styles. Actually, I think Brian Anderson, who is the lead of Rust, said that they are out of the color, like the brownish ones, and now they only have black ones. So if you want brownish ones, has a chance. All right, so that's it.